we determine a limit, what is the first step we have to perform? What is the first thought?
To plug in.
Yes. So when I plug in here, I get negative infinity. When I plug in here, obviously I get infinity. So this is one of the list of 7 indeterminate cases, right? So it's infinity minus infinity. This is an indeterminate case. We don't know what that is. These are symbols. So we don't know what they are, actually. You can say infinity for me is 2 million. For somebody else will be 10 million. So I don't know what, this is an indeterminate case. So in this case, the option is to rationalize the numerator with the conjugate of the numerator. So this is it. And x minus the square root of x squared plus 2x. So I was going to highly recommend, please redo the tests several times, all tests and the old tests in preparation for the final. So limit as x approaches negative infinity. When we multiply these two, we get x squared minus 2x. Because it's a plus b times a minus b, so a plus b times a minus b, which will give us a squared minus b squared. So this squared minus this squared, but I have to distribute a negative sign after I square this. So these two will go away. The denominator has to be factored, so I will factor out the degree, as you remember, 1 plus 2 over x, and then I have to factor it out. And when I factor it out, it will be the square root of x squared, but since x approaches negative infinity, I have to factor out this. So this piece, just the square root of x squared, will be replaced by negative x. So then the numerator is just negative 2x. The denominator is x minus negative x. So this is x plus x, and the square root of 1 plus 2 over x. One more step in which we factor out x from these two terms, because this is a product. So this is limit as x approaches negative infinity, negative 2x at the top, and x in the denominator. And that's what I really wanted, to simplify these two. So I have 1 plus the square root of 1 plus 2 over x. And at this point, I know what I have to do. X approaches negative infinity, and this will approach 0. So the numerator is negative 2, and the denominator is 1 plus 1. So it's 2. So the final answer is negative 1. And I have to write. That means that y equals negative 1 is a horizontal asymptote at negative infinity. Any questions so far on this problem? Any questions? Before we move on to B, as in boy. Gia, is this okay? Every step?
Yes, thank you.
Thank you. Okay, moving on to B. So this is B from the old test. Let me see, what is B. Yes. So first we have to look at the function and simplify it fully, and then we want to look at the limit as x approaches 1 from the function, where this is f of x. Okay, perfect. So first I have to simplify the function, and I have 2 x minus 1 over the absolute value of x minus 1. But the absolute value of x minus 1 has two options. Either x minus 1 when x minus 1 is greater than or equal to 0, which means this, or negative x minus 1 for the rest. So then this will have two options, because this has two options. If this has two options, the whole function will have two options. One option would be 2x minus 1 over x minus 1, which is going to give us 2, but not when x is 1. Not possible. So when x is greater than 1, and the other one is 2x minus 1 over negative x minus 1, which will be negative 2 for x less than 1. So at this point, I'm asked to find the limit from either side. Well, I have to show that the limit from the left of 1 is negative 2 from the left, and the limit of f of x as x approaches 1 from the right is 2. From here, I conclude that this is D and E. But I have to show the work, and I have to show both limits. Is this okay?
Yes. Can we do C too?
Yes. Let me see what is C all about. A, B, C. Yes. Yes, many of these problems were done in class. If you go back to the notes, limit as t approaches 1 from the right, 1 over t minus 1 minus 1 over natural log t. So here I have two pieces, and I cannot apply the limit law because the limit of this is not a number. And the limit of this is not a number. I don't care. If one of them is not a number, I can't continue. So I'm trying to simplify the function by finding the least common denominator, which is t minus 1 times natural log t. And this is not 1, it's t. I'm sorry, I didn't copy it correctly. Okay. So then this needs a natural log t, and this one needs a t minus 1, because the denominator is a product of the two. So then t times natural log t minus t, but plus 1. Minus t and plus 1. And now, at this point, I can plug it in. This is 0, this is negative 1 plus 1, so then the top is 0. This is 0, this is 0, the denominator is 0, which I like, because I have a method that deals with the 0 over 0, and that is called, anyone? Thank you. So let's differentiate. So this is limit as t approaches 1 from the right. Now, this is a product. This is negative 1, this is 0. But I have to use the product rule. So t prime is 1, so I have natural log t plus t times natural log t is t over t, which is 1. I differentiate this, I get negative 1, and I differentiate this, I get 0. I thought it was going to be longer, so I'm going to erase this. So when I differentiate this, I get 1 times natural log t, and plus t minus 1 times the second one prime, which is 1 over t. Okay, so these two go away. So limit as t approaches 1 from the right, from natural log t over natural log t. T over t will be positive 1 minus 1 over t, which will be 1 over t. Again, the top goes to 0. This is 0. This is 1. 1 minus 1 is 0 again. So I apply L'Hopital's rule. Limit t approaches 1 from the right. The top prime, 1 over t. The denominator prime, 1 over t. This is 0. 1 over t prime is negative 1 over t squared, but I change that to plus. Plus 1 over t squared. Good. At this point, what I'm going to do is, I see the denominator has 1 over t in common. So limit t approaches 1 from the right, 1 over t over 1 over t, 1 plus 1 over t. 1 over t from the top with 1 over t from the denominator, because they are factors. And now when 1 approaches, although I don't even need it, because 1 approaches, t approaches 1 from the right. The top is 1, the bottom is 2. I don't need anything. Same thing. I don't even need to simplify. I just plug in at that point, and I get the same thing. The top goes to 1, the denominator goes to 2. Good. Anything else? I would like to talk about the extra credit from the test, since we're talking about limits. And I'm just going back here. I just realized that the solutions I posted, they didn't work out. It's not, they're just half a page. I'm not sure why that happened. The test, not the solutions. I have to download the file again for the test. Sorry about that. I'm glad I noticed. Yeah, it's just 1 page. It's very weird. That's very weird. I don't understand why. Okay, so let's talk about that last limit. Okay, I'm just trying to see. I don't have it. So what was the limit? Anyone remembers what it was exactly? Almost there. Okay, so it was a limit as h approaches 0 from the integral from 2 to 2 plus h, the square root of 1 plus t to the third dt divided by h. Okay. Let me see. Okay. Good. So when we are asked to find the limit, what do we need to do first? I don't care what the limit is all about, right? Except if it looks like this. I have no choice here. I have to simplify the function by finding the least common denominator because I cannot plug it in. Here also is somewhat of an exception because I'm asked to simplify the function first before I even look at this limit. So it's somewhat of an exception. So in general, what do I need to do when I'm asked to find the limit?
Generally, plug it in first?
Yes, I have to plug it in to see what it is. Okay, so once I plug it in, let's start with the denominator. Where does the denominator go?
0.
Yeah, perfect. Now let's look at the numerator. When h approaches 0, it's the integral from 2 to 2. What is that?
It's also 0?
Of course. We like this situation. Why?
So you take a derivative.
Yes, we apply L'Hopital's rule and we differentiate both sides, both the numerator and the denominator. Okay, perfect. So let's start with the denominator. What do I have when I differentiate h? Because that's the variable. H approaches 0.
1.
Perfect. When I differentiate an integral, what happens when I differentiate an integral? What do I get?
It's the opposite, right? So it goes away.
Yes. So I get the function, but remember, and you also had an example of differentiating a function in the form of an integral further up the road in the test. So I have to write the square root of 1 plus 2 plus h, everything to the third, times this prime, which is 1. There is nothing I can have to write. So now what do we do next?
Do we try plugging in again?
Of course. And what do we get?
3.
Right? Because it's 2 to the third, which is 8. 8 plus 1 is 9. The square root of 9 is 3. This is it. That's it.